Okay, so we are going to graph other functions today. We are going to start with tangent, and we're going to graph it, and then we are going to graph, I want to say secant, and then, yep, we're going to do the other two. Okay? All right, so let's talk about tangent. Okay? Refresh my memory as to what tangent is in trigonometry. In trig. Not on a coordinate grid. Sine over cosine. Okay? So trig is sine over, tangent is the sine of x over the cosine of x. On our unit circles, it's y over x. Okay? Right? We learned that way back in first semester. Okay? So, when we were graphing sines and cosines back before semester break, we said that their domain was all real numbers because we could put any angle into sine, any angle into cosine, and it would work out. Right? Is that the case with tangent? Can I put any angle in to tangent and get an answer? What are the two restriction type things in mathematics? What do you got? Sounds like you said you can't divide by 0. Is that what you said? Okay. So the first one is we can't divide by 0, and the second one is we can't take an even radical of a negative number. Right? So those are the two things that we have to look for. So in tangent, are we dealing with radicals? No, so we don't have to worry about that one. In tangent, would it be possible to divide by 0? Yes. When would we be dividing by 0? When my cosine value is 0. So those are no-go spots when cosine is equal to 0. So my domain here of tangent is all real numbers except when the cosine of x can't equal 0. Well, when does cosine of x equal 0? Cosine is x or y on the unit circle? X. So when are we talking here?
0.
So we're talking pi over 2 and 3 pi over 2. So we're talking at those two. Okay? So are those the only two?
No.
What else?
7 pi over 2. Wait.
Can I go 5 pi over 2 first?
Yeah, that's what I meant. I went too far.
Can I go negative pi over 2? Right? So at all of those, we're dividing by 0. Right? On a graph, when you're dividing by 0, what gets put there? Because we can't divide by 0. So how do we write undefined on a graph?
You know, it's blank. A straight line at 0.
Think back.
There's a hole
because we didn't factor out something.
Everything
close.
else too shallow. It's a circle.
Nope. What goes there?
No point.
No. Solid point would tell me that it would work there.
An open point.
Got no hole.
What?
It's something else. It's not a hole. When there's restrictions in my domain, what goes there? What kind of a dashed line?
Straight dash.
That's redundant.
They should get the dash.
We're gonna
line
go
first.
diagonal. We're gonna go
Oh.
vertical. We're gonna go horizontal.
Vertical.
What are we gonna go there?
Don't look at me like that.
What do we call it? Say it louder. So we got a
Vertical.
vertical asymptote. So at all of those points,
Isn't that the thing
there's
we're gonna do?
vertical asymptotes.
No, stop.
Okay? So there's vertically dashed lines at all of those points. Okay? So if I'm graphing this function here now, I would first have to set up my horizontalness scaling. So let's go pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And at all of those over 2's, I'm going to have a vertical asymptote. Can my function ever cross a vertical asymptote? No. Okay? So I'm going to have zones that I'm going to have functions in. Okay? When would my function, let's call it tangent of x, when would that function be equal to 0? So when is that?
180 degrees, 360.
No. Remember, you guys told me my function, tangent of x, was sine of x over cosine of x. When is that fraction equal to 0? When sine is 0. Where is sine equal to 0? So this would be at the whole pi's is what Liz was saying, right? Okay. So at negative pi, pi, 2 pi, what about 0?
Yes.
Is sine of x equal to 0 at 0?
Yes.
Yep, 0, negative 2 pi. So those are all going to be at when the function is equal to 0. When is my function equal to positive 1. When would my function be equal to positive 1? Okay. I like one of those. I don't like the other one. Okay. How do I know when my function is equal to 1? Are equal? So that's going to be at pi over 4, we said. What's the next one? 5 pi over 4. What would the next one be? 9 pi over 4? Yep. What would a negative 1 be? What you got? I got negative 7 pi over 4 and I got negative 3 pi over 4. Or negative pi over 4.
Because the negative 7 pi over 4 would bring you all the way back. I'll circle.
But the negative pi over 4 is not right.
Yeah, because that would bring you down just there.
Yep. Yep. Okay. So we can put in those. So it's equal to 1 at pi over 4. Pi over 4 is halfway between 0 and pi over 2. 5 pi over 4 is halfway between pi and 3 pi over 2. 9 pi over 4 is halfway between 2 pi and 9 pi over 2. Negative pi over 3 pi over 4 is there, and negative 7 pi over 4 is there. With me? Okay. What's the other easy one? When is tangent of x equal to negative 1?
3 pi over 4 is 7.
So that happens when what?
When cosine and sine are opposite.
So we could say when sine of x equals negative cosine of x. And that happens at, what did you say, 3 pi over 4?
It's just the reciprocal of the last one. Or not the reciprocal, the opposite of the last one.
And 7 pi over 4? And negative pi over 4? And negative 5 pi over 4? So the opposites of the other one, right? Okay. Back to our graph. So 3 pi over 4 is here. 7 pi over 4 is here. Negative pi over 4 is here. Negative 5 pi over 4 is here. And negative 9 pi over 4 is there. Okay. So it starts along the asymptote, comes up, and waves on through. let's check it with pi over 3. Okay? Pi over 3 is, if I'm looking at a unit circle, pi over 3 is between pi over 4 and pi over 2. Agreed? So that would be somewhere up in here. So it should be bigger than 1 upon checking. Correct? Okay. Well, the tangent at pi over 3 is going to be the sine value, square root 3 over 2, divided by the cosine value of 1/2. Square root 3 over 2 times 2 over 1 gets me the square root of 3. What is the square root of 3? Approximately. It's 1 point something, right? It actually ends up being 1.732. Okay, approximately. Would that fit our graph? Is my purple circle at about 1.7? Yeah. Because it's above 1, right?
Oh.
Yeah. So that is the graph of tangent. Questions, comments, concerns, clarifications? Make it easy on yourselves. Okay? Make it easy on yourselves when you're graphing this stuff. Okay? Let's do the next one. Next one is secant.
Anybody else for the AC or
Just you. What is, in terms of trig, what is secant? Opposite of cosine or reciprocal of cosine? Reciprocal of cosine I like more. Okay. So, when would the secant of x, well, first off, tap the brakes. Let's find the domain of said secant. All real numbers, but what? So when cosine, so cosine can't equal 0. So that happens when? Pi over 2? 3 pi over 2? 5 pi over 2? And so on and so forth. Yes? Okay. Again, what does that mean? What does it mean? What kind of asymptotes? Vertical ones. Yep, good job. Okay. So we have vertical asymptotes at all of those. So vertical asymptotes at all the over 2's. Okay. Can secant, oops, not secant of 0, excuse me, secant of x, can secant be 0? So that's saying 1 over cosine equals 0.
No.
Why not?
Because the one's on top, and in order for it to be 0, the 0 would have to be on top.
Bingo. Yep, exactly. Okay? A fraction is only equal to 0 if the numerator is equal to 0, and this numerator is 1. So can secant ever be 0? No. So what does that tell you?
There's an asymptote.
Horizontal asymptote.
No.
Never.
What does that tell you?
It never crosses the x-axis.
It never crosses the x-axis. So this function is not going to wave through. Okay? So right away, you know that this function is not going to wave, because wave functions have to cross the x-axis. This function never crosses the x-axis. Okay? So let's go with 1 then. When is secant of x equal to 1? So when is secant equal to 1? When cosine is 1. Where is cosine of x equal to 1? Where is cosine equal to 1? Nope, you weren't right.
2 pi is all. Because pi, it would be negative. Just pi. 2 pi.
And what? Negative 2 pi? Positive 2 pi?
Yes.
Missing 1. And 0. So at 0, at 2 pi, and at negative 2 pi. When is secant equal to negative 1? When what? Say louder.
Cosine.
when cosine equals -1. And that happens.
Negative pi.
-pi,
Zero. Wait.
Not 0 pi.
pi,
3 pi.
3 pi,
5 pi.
-3 pi,
Okay. 5 pi.
5 pi. So the odd pi's, right?
Yes.
Okay. So the odd pi's, but not 0.
Is 0 considered an odd or an even number?
Nope.
None of the above.
Zero's itself. No. Okay. So put those two together now. Okay. Or actually put all three of those together now. Red tells me that it never crosses the x-axis. Orange tells me that in these zones, the orange zones, that's where it is. And purple tells me that in the two purple zones, that's where it is. So I can't cross the x-axis. I have 3 of them where it's equal to 1 and 2 of them where it's equal to 0. What does my graph look like? Say it louder. Parabolas. Oops. I will tell you that you're much smarter when you're paying attention.
You just he's not wrong.
I think that's for everybody.
That's why I like
Yes.
sitting in the front, because when I sit in the back I horse around.
Exactly.
Yeah, Brennan.
And then we get formative assessments.
Yep.
That we fail.
Okay?
Yep.
Right? Now, let's test it. Give me a point that we should test it with.
Pi over 4.
Pi over 4. Okay? So pi over 4 is somewhere in here. So we should be more than 1 with it. Correct?
Yes.
Okay? So let's go pi over 4 down here. So the secant at pi over 4 is equal to 1 over the cosine at pi over 4, which is 1 over the square root of 2 divided by 2. Right?
Yes.
Okay? So doing that fraction, that's going to be 1 over 1 times 2 over the square root of 2, which is going to just be the square root of 2. What approximately is the square root of 2? More than 1, right?
Yeah. I was gonna say
It's like 1, it's actually, I think it's 1.414. And the only reason I know that is because the area code when I was growing up was 414 for me. So that's how I remember it. Okay? Alright? So 1.414, which is more than 1, correct? And that does that fit our, oops, I gotta go up even farther. Does that fit our graph? So those are the graphs of secant and tangent. Okay? For everyone, now, you will need to sketch the graphs of cotangent and cosecant over the interval -2 pi to 2 pi, which is what we just did. So you've got to do the other two. Please do them on a separate sheet of paper because we will be collecting it from everyone on Friday. Okay? Alright? So those graphs are due on Friday when you come to class. Again, you'll put them in the LINS 7 to 8 basket. Unless you're watching this on the line and you're not a LINS 7 to 9 person, then you'll put it in whichever grading teacher you have. Okay? Much better today than you were yesterday.